Hello. Hi, welcome to our talk, Pwned in Translation, from subtitles to remote code execution. Quick introduction. We're Omer and Omri, security researchers at Checkpoint. And, let's jump in. So this research was conducted about a year ago with the intention of presenting a new concept, a new attack vector, and we call it subtitles drive-by attack. And it's important to remember that this is not about the vulnerabilities, even though there are plenty of those. It's the notion that subtitles are now considered dangerous. So let's back up a little bit. This is how we used to watch movies at the local cinema. But as technology evolved and the internet became faster and we got lazier, movies entered our living rooms. And it could be a laptop, a smart TV, a Raspberry Pi, an actual media center. The streaming options are endless. And they're designed with ease of use in mind and to take care of everything for us. They pull all the metadata for us. They pull the trailers, thumbnails, plot info, and subtitles. Okay, so yeah, subtitles, it's a thing. These were the statistics of daily downloads from one of the main repositories, Open Subtitles, ranging from 7 million up to 10 million a day. Obviously, subtitles are used for translation for non-native English speakers like ourselves, but not only. Now, to convey the necessity of subtitles, we'll use the power of memes. So, they're used when you're watching a foreign film or a TV show like anime or a pretentious French film. They're used for convenience in case there are any sort of sound limitations. And they're used in Guy Ritchie's movies. Sometimes they also provide critical notes for the hearing impaired. But they usually have a lot more than just text display. So let's explore the subtitles landscape. We all know SRT, subrip text, the most basic subtitle file. It supports a basic set of HTML tags like bold and italic and etc. And there's also the sub format that stands for subviewer. It supports basic formatting like colors and fonts. But sometimes sub actually stands for MP-sub that supports none of the above. And at different occasions, sub can also stand for micro DVD subtitles. Now, this sub supports formatting, color schemes, font configuration, subtitles location, and different character sets. Another common format is the Substation Alpha. It's a bit more sophisticated. It supports predefined style names, fonts, complex color palettes, outlines, shadows, alignment, margin, alpha level, and encoding. But it gets even more impressive as we move on to advanced Substation Alpha. Now, the ASS contains all the functionality of SSA with some interesting additions. Okay. So the ASS format supports scaling, angle shifting, binary image embedding, binary font embedding, drawing. Here we actually drew a small dinosaur in the subtitles. And the specification even mentions system commands functionality. It's allow executing a specified program as a background task, and we truly hope no one ever implemented this bizarre feature. So, back to our subtitles. There are actually shitloads of subtitles. All in all, during our research, we encountered more than 25 subtitle formats. Some are binary, some are textual, none are well documented. So we asked ourselves, can the unregulated nature of this subtitle madness be exploited? Okay, so our first target was the most notorious streaming platform we know, Popcorn Time. This multi-platform Netflix for pirates integrated a deadly combination of a BitTorrent client, a video player, and endless scraping capabilities. It's all under a very friendly graphical user interface. Even my mother uses it, which is a key lead in every research we conduct. So this beautiful WebKit-powered interface is packed with movie information and metadata. It presents trailers, plot summaries, cast information, cover photos, IMDb rating, and much more. But the way it does it so elegantly beautiful is by using a platform that supports web technologies. Now, technologies as HTML5, CSS3, and JavaScript build on top of a Node.js engine. Okay, so the two main frameworks that allow this are NWJS and Electron. Both are multi-platform, utilizing Chromium and supports external plugins. Okay, so we know they look good, but are they vulnerable to anything? Well, these underlying technologies are very interesting from an attacker's perspective, because what might be considered weak vulnerabilities, at least in bug bounty programs like XSS, can actually result in code execution, because Node.js is essentially a JavaScript engine with server-side capabilities. And all you need to do in Node.js in order to pop a calculator is use this code, which imports the child process library and uses its exec function with calc as the argument. Now, we'll talk about this in a minute, but back to popcorn time. To make life even easier, subtitles are being fetched automatically for both the viewer convenience and the attackers, and the question remains, can this behavior be exploited? So behind the scenes, Popcorn Time uses Open Subtitles as the sole subtitles provider. With over 4 million entries and a very convenient API, it is an extremely popular repository. So this API does not only allow for search and download of subtitles, but it also has a recommendation algorithm to help you find the right file for your movie and release. We'll dive deeper into that process a bit later. It turns out to be a key step in our strive for world domination. So gaining some knowledge about Popcorn Time infrastructure, let's see how subtitles make the way from a download to screen. So our journey begins as soon as the user starts playing a movie. Now, Popcorn Time downloads subtitles and converts whatever format it gets to an SRT timecode. Okay, so after the conversion, it's passed to the update display function. Now, this function will create an HTML span containing the subtitle text. So, since the SRT format supports HTML tags, and this is a WebKit, they didn't need to make any implementations for HTML. It's obviously built with HTML to its core. But perhaps we can write other things than HTML, like JavaScript, unsanitized JavaScript within a Node WebKit application. Okay, so let's try this simple one. This is how a standard SRT file looks like when you open it. As we already know, it supports HTML tags. But what if we try to load an image that doesn't exist and provide it with an onError attribute? Well, XSS 101, we know the onError attribute can run JavaScript. So brace yourself. Yeah, we got our first vulnerability for the research. We managed to make subtitles pop a message box. That's not good enough. Let's try something a bit more advanced. Okay, so what if instead of the alert, we write a code to clean things up, remove the revealing icon of the broken image, and append our malicious payload to the page, which would dynamically create a script loaded from a remote host, our host. Okay, so needless to say, just as we showed earlier, Evil.js will utilize the Node.js capabilities of the framework to run a process. Let's take a look. This is Omer's cat, Diego. You can see the user opening popcorn time, chooses his favorite movie, starts playing. Chooses the subtitles. Here we get an attacker's perspective. Thank you. Okay, so we were able to make malicious subtitles for popcorn time, which is great, but how would the user get our subtitles? So let's talk a little about the subtitles supply chain. With an average of 8 million daily downloads, Open Subtitles is the world's largest online community for subtitles. Their extensive API is widely integrated into many other video players. Among the basic functions you would expect to find in such APIs, the search and download, the smart search capabilities is essentially a chained function requesting all relevant subtitles from the server, and it sorts and ranks them, returning the best matching subtitles for your movie and release. Let's take a look. Okay, so the smart search. Now, looking at the request of the smart search being sent to the Open Subtitles API, we can see the only argument passed is IMDb ID. Now, along with the required languages, in this case, all languages. While the response contains all matching subtitles to that IMDb ID. Okay, so obviously Popcorn Time automatically loads the subtitles with the highest rank. But what determines the rank? So, skimming through the documentation, we bumped into this ranking scheme. So we can see that the score is based on 5 criteria. Movie hash, tag, which is file name, IMDb ID, FPS, and something called others. So also extra points are being credited for being an admin or a trusted partner. But since the only argument sent by Popcorn Time is the IMDb ID, if we would have wanted our malicious subtitles to be chosen by the API, the maximum points we could have get is 5, us being anonymous uploader. So, a bit discouraged by the documentation and the score we saw in other popular movies, which were higher than 5, we turned to the source code of the Open Subtitles API. We obviously learned a valuable lesson. If you truly want to break something, looking at the documentation is not the way to go, because the source code revealed an undocumented behavior. The match tags function is called either way. Okay, but what is match tags? So, the match tag function will break the file name of the movie and the subtitles to tags. Now, a tag is basically an isolated word or a number found in the file name, usually separated by dots and dashes. And then a short loop checks how many shared tags does the subtitle file name and the movie file name have in common. After that, a weird formula is taking place. The amount of shared tags is divided by the number of movie tags and multiplied by a max score of 7, which is the max score that can be assigned in case of full compatibility. So, a bit complicated. Let's see a demonstration of this function's behavior. Let's assume that this is the movie file name streamed by Popcorn Time. This is easily checked using a sniffer. And this is a name of a candidate subtitle file name offered to the ranking algorithm. So the code first splits the movie file name into tags. It then splits the subtitle file name. And the match tag functions checks how many shared tags they have. 3 in this case. So the API then goes to its formula, which is share tags 3 and divided by the tags in the movie file name 8. We see that on the left. Multiply by max score, which is a constant number of 7. This gives us the final score of 2. Okay. Well, this behavior makes it trivial for us to achieve full compatibility, because all we have to do is name our malicious subtitle identical to the movie file name. So this gets us full compatibility, 7, plus the IMDb ID 5 points we already had, and we get 12 points. But wait, there's more. Because these are the recommended subtitles for some of the most popular content available online. Deadpool, Frozen, Inception, Snowden, and Westworld Season 1, Episode 1. These graphs show the score of the 7 most popular languages in the world, displaying their average and their highest score. So scanning automatically through a bunch of popular subtitles, we notice that the highest score a subtitle got was 14, while the average is around 10. So at this point, we show that we can consistently achieve a solid score of 12, higher than the average, but less than 14, so we're obviously still unsatisfied. And as you recall, extra points are credited for being a ranked user. Calling Open Subtitles website, we found this table. Now, apparently, all it takes to become a gold member and earn extra 3 points is 101 uploads. So we sign up to Open Subtitles, and 4 minutes later and 40 lines of Python, we were golden. Okay. So we wrote a small script that gets the score of all subtitles available for a given movie. As you can see, our subtitle has the highest score of 15. So what this basically means, that given any movie, we can force your player to load our crafted malicious subtitles and exploit your machine. Okay, so let's see what else we can do with it. Omer will take it.
Hi. So Kodi, which is formerly known as XBMC, is an award-winning open source cross-platform media player. It is available for all major platforms, 72 languages, and it is used by over 40 million users around the world. So it makes it the most common media center software around. And Kodi is also a popular combination with Raspberry Pis and Smart TV, making it kind of interesting from attacker's perspective. So this is the screen that is displayed when a user wants to download subtitles using Kodi. And this is the request that is being sent by Kodi. We recognize it as we're already kind of familiar with Open Subtitles API structure. And this is the code that is actually fetching the subtitles. So let's go over it. First, the search subtitle function is called, and the response is saved into a variable called search data. Then a for loop will iterate over these results, extracting the information from them and formats them into a string called URL. Then each of these created URL is sent to the add directory item function, which in return results in this screen. Now the user can simply select his desired subtitles. But let's focus on that URL string for a moment. So since Open Subtitle is obviously open, the attacker has complete control over the file name parameter, which is received under the value of sub file name. And here we see how each of these 4 keys in item data are formatted into that URL string. So given the fact that the attacker completely controls the file name, what can we do with it? So usually the file name will be something like this, subtitle filename.srt. But what if afterwards we append the ampersand sign, and then something like this? So this would effectively overwrite the original link and ID parameter, which we originally didn't have any control over, simply because this is a string and it is being parsed by a very basic split function. How does this help us? Well, once the user chooses his subtitle, the download function would be called. And the argument to that download function are derived from that URL. And these are the arguments we can now control: the ID and the link. So how does this function behave? First, it uses Open Subtitle API to download the subtitles based on the ID given to it. But the interesting part is, what happens if it fails, if the ID does not exist? Then we go to the not result branch, which downloads a zip file from the link given to it. So by changing the ID to something that doesn't exist, such as -123, and overwriting the link to point to a zip file that is stored on our servers, we force Cody to download a remote zip file. Now, after download, the zip file is sent to a function called xbmc extract. And here, instead of using the standard library for any zip extraction, Cody decided to implement their own, which, as we all know, is usually a great idea, right? So downloading an arbitrary zip file from the internet is definitely careless, but chaining this behavior with another vulnerability we found in Cody built-in extraction made it lethal. So let's see. What Cody built-in extract archive function does is building a file path based on the folder names inside the zip. But what Cody neglected to handle are folder names that contains 2 dots. So I don't need to tell you guys, we have directory traversal here. So all we have to do is create a zip archive that contains dots as folder names, and then we can make the extraction create a Python script instead of the add-on script itself, which will be immediately called again, thus executing our code. So that would be the second vulnerability for today. Let's see that in action. So the users open up Cody, look for his favorite film. Now, this is the subtitles window we discussed earlier. Here it's loading everything. So like we told you, we completely control Open Subtitles, so we don't have nothing to worry about. Our first top 3 hits are our malicious subtitles, so he can choose whatever he wants. Again, we get the attacker perspective. And we get a reverse shell. All right, moving on to the next victim. Well, Popcorn Time definitely marked the rise of streaming apps, but being temporarily shut down by the MPAA, it left users looking for alternatives, and Strem.io offer just that. Like Popcorn Time, it is designed with ease of use in mind, and has quite similar user interface. By the way, this is also the platform that both of us use at home, so we thought it would be fun to give it a shot. And interestingly enough, Strem.io shares a few characteristics with Popcorn Time under the hood. Most importantly for us, it is also a WebKit-based application. And, you guessed it right, it uses Open Subtitle as a subtitle provider. So we just tried the same trick we used on Popcorn Time. You can actually see the broken image icon at the bottom, but no message box was popped, so that didn't work. Apparently, our JavaScript has been sanitized, and it was time to dig a little deeper. So Stream.io code is archived as an ASR file, which is a simple tar-like format that concatenates all files together just without the compression. We used the Node.js library to extract it, and we got all the necessary files we needed in order to inspect the code. Extracting the source code and prettifying it, we realized that any text added to screen is passed through Angular Sanitize. This sanitize service will parse an HTML and only allow for safe and whitelisted markup and attributes to survive, thus sterilizing our string so it contains no scripting expressions or dangerous attributes. Now, having to use only static HTML tags with no scripting capabilities really limited our options, so this called for quite a creative solution. If you've ever used Stream.io, you must be familiar with the Support Us pop-up banner. Now, we know that we can use HTML tags, right? So what if we present the Support Us image to the user using the image tag, but we surround it with an href tag? This way, there is no JavaScript to be sanitized, and once the user would click the pop-up in order to close it, he will be redirected once again to our malicious JavaScript. Again, popping a calc. So let's take a look at our third vulnerability for today. And there's a click it in order to close it, and we get a calc. Yeah. So realizing the disastrous potential of subtitle as an attack vector, we move on. Now, I'm pretty sure that there is no need to introduce our next target. With over 180 million users, VLC is one of the most common media players out there. It's open source, portable, and cross-platform framework. It is available for almost any platform imaginable. At this point, Yanai Livne, a former member of our team, joined us, and much of the work shown here is due to his contribution. So VLC. VLC is in fact a complete multimedia framework, just like DirectShow or GStreamer, if you're familiar, where you can load and plug in many modules dynamically depending on the necessity. And actually, the core framework is just used to do the wiring and the media processing. So from inputs, whether it's files or network streams, to outputs, whether it's audio, video, on-screen or on a network, it uses modules to do most of the work at every stage, like various demuxers, decoders, or filters. And being described even by its own authors as very popular but quite large and complex piece of software, we are confident that we can find subtitles-related vulnerabilities. So let's go over them. Textual subtitles are parsed by VLC in a demuxer called subtitles.c. These are all the supported formats and the respective parsing function. And yes, that's a lot. And the demuxer only job is to parse the different timing code of each format and send the subtitle to its decoder. Now, other than SSA and ASS that are decoded by a dedicated library called libASS, all other formats are decoded by VLC's own decoder, subsdec. Inevitably, things are about to go wrong. So subsdec takes every subtitle, let's take SRT for example, and parse its text field. It will create two versions of it. The first is a plain text version with all tags, attributes, and styling stripped off. This version is used in case later rendering will fail. The second, more feature-rich version is referred to as the HTML subtitle. HTML subtitle will contain all the fancy styling and attributes such as fonts, alignments, etc. After being decoded, subtitles are sent to the final stage of rendering. So, going over the VLC subtitle-related code, we immediately noticed that a lot of parsing is being done using raw pointers instead of built-in string function, which is generally a bad idea. Now, let's see an example of it. Again, this is how the basic SRT subtitle will look like. And this code uses the PSZ subtitle variable to parse the subtitle 1 byte at a time. In this case, the code just identified the HTML font tag. So it then moved on to consume it attributes, the face attribute in this example. The decoder will continue reading from the buffer until the closing bracket is met. What this means is that in case the bracket is missing, the parser will just keep on reading, resulting in an out-of-bound read vulnerability. That's 4 for today. And while auditing the code manually, we also started fuzzing VLC for subtitle-related vulnerabilities. Obviously, our weapon of choice was the brilliant AFL. This security-oriented fuzzer employs compile-time instrumentation and genetic algorithms to discover new internal states and trigger edge cases in the targeted binary. So getting the fuzz command was actually a bit tricky. We created the corpus and created the dictionary, but our main obstacle was the fact that our fuzzing server simply had no GUI. So we overcame this challenge by using the transcode functionality. This option will make VLC convert a movie from one codec to another while attaching the subtitles, but presenting nothing, which was perfect for us. So moving on to the corpus. Corpus is a set of initial test cases comprised of valid files that represent the protocol or the functionality being fuzzed. Now, we plan to start with SRT and ASS simply as these were the formats that we researched first. So for our corpus, we cherry-picked some of the various files that incorporated some of the more exotic features that Omri discussed earlier. And this is the basic time convention of the SRT format. And we intended on adding more formats to the corpus as we go along, but the amazing thing is we didn't have to, because AFL just blindly built valid subtitle files of different formats with zero knowledge. In this case, he created the JSS format all by itself. So this is a demonstration of one of AFL's greatest strengths, assembly-level instrumentation, because the odds of a traditional fuzzer simply flipping bits to convert the time convention of SRT and turn them into JSS are extremely low. However, through assembly-level instrumentation, AFL notices how minor mutation triggers slightly different code path and uses those as a seed for further fuzzing rounds. So, great job, AFL. And it didn't take it too long to lock down on a vulnerable function called ParseJSS. Now, JSS stands for JCO subscript files. And this format is a really flexible format, allowing some really interesting functionalities. It relies heavily on something called directives. A directive is a series of characters strung together, and they can determine the subtitle position, font, color, so forth. And they come in two forms. They come either as a global directive that affects all subtitles below it in the text file, or as an inline directive affecting only the current line. So these are some of the more common JSS directives out there. This is T, it stands for timer, and it is used to set the timer resolution 100 units a second in this case. S, which stands for shift, and it will cause all events to occur 20 time units sooner than usual. F will set font number 3 because you can predefine up to 10 formats to JCO sub font 18, which is a monocolor font available in JSS. For an inline directive, here's an example. CP2 will display the following text using color palette number 2 that can also be predefined by the user. So yes, it's really weird, and VLC doesn't do a great job in parsing those. Let's see. Looking at the basic ParseJSS function, we can see that VLC iterates over the lines with a while loop, again, 1 byte at a time. It processes time codes and a handful of supported directives, and the text itself, obviously. And the crash found by AFL was due to an out-of-bound read while trying to skip unsupported directives. Here and throughout, PSZ text is a pointer to a null terminated string allocated on the heap. And the code assumes that a directive is always followed by a space. Therefore, it will look for that space to indicate the end of a directive. In case a directive is written without any following spaces, this while loop will just skip the null by terminator and overrun the buffer. So that's number 5. And this got our attention to the ParseJSS function, and we soon manually found another 2 out-of-bound read issues in the parsing of directives that were supported. So moving on with the JSS format, we stumbled upon the color and font directives. As you can see, the code includes a double increment to skip from the directive right to the argument. But in case a directive didn't contain any argument to follow it, meaning it ended with a null termination, this double increment would just skip the null terminator. But let's see how this code is combined within the bigger picture. So this entire chunk of code is within a while loop. Here's our double increment right there. And skipping the null byte, we remain in that while loop, copying from PSZ text to PSZ text 2. However, PSZ text 2 is only the length of PSZ text plus 1. So while we are reading out of buffer at one point, we are actually writing out of buffer at another point. And this 6th vulnerability, a heap-based overflow, actually allowed us ultimately to execute arbitrary code. At another case, you can see that when the parsing loop reaches a null terminator, in a very specific case, it intentionally decides to skip it, making this number 7, and in my opinion, the weirdest of them all. So let's talk about exploitability for a second. These bugs are definitely not trivial to exploit. However, it is interesting to note that the main binary of VLC is not ASLR, or pi in Linux. By design, the main binary is just do the wiring between libVLC core and the plugins, but it offers some quite useful gadgets. For example, this gadget that will find whatever symbol is in RSI and call it with RBX as an argument, which is quite useful, right? So for a quick POC, we had Yanai to develop an exploit for this vulnerability, for the moment ignoring ASLR. Let's see a demo of it. And we get a calc. So, thank you. Let's sum up this research. We discussed the complete madness that is the subtitle landscape. We saw we had over 25 subtitle formats, none of them well documented, without any dedicated library, and 0 standardization between players. We were able to gain full remote code execution on 4 major platforms. Now, please note that these were the only platforms that we looked at it. So it means that other platforms out there are probably vulnerable to subtitle drive-by attacks. We are also able to manipulate the subtitle repository ranking scheme, thus taking control completely over the entire subtitle supply chain. And this means that what we just presented is a new malware delivery system, completely transparent and requires no user interaction, which in our case included over 220 million potential victims. And the notion of attackers being able to upload malicious subtitles to a major repository and forcing different players to download them should now be taken into account as a new valid attack vector and prepare the security vendors and industry to mitigate it. Now, for the moment you've all been waiting, Omri and myself, we made a little bonus for you. We curated our favorite calc popping scenes into a beautiful compilation. Actually, on the first draft of this talk, this bonus was titled 2 girls, 1 calc. Yeah, but then we almost got fired, so we had to tone it down a little bit. Here it is. Enjoy.
No.
Wait, forgot about the sound.
Sound is important.
PL? Okay.
People sometimes make mistakes.
Yes, they do.
How can it talk?
It's not a real voice. This box just interprets signals from the computer and turns them into sound.
Shall we play a game?
Oh.
I think I missed him.
Yeah, weird, isn't it?
Yeah. What is it?
Is that what I think it is? Mm-hmm. It's beautiful.
God damn it, what is it?
You want to play this? Okay. I'll play with you. Come on. Okay. You want to play with? Okay. Say hello to my little friend. You want to play with? Okay. Good. Okay. You like that? Huh? You want more?
And that's just a sample of the exciting exploits ahead in our first feature motion picture.
Holy memoranda, folks. Make a note not to miss it.
Good thinking, Robin.
Thank you.